Okay, in this video we're going to review the Pythagorean theorem and the distance formula, and also through three illustrations kind of discuss how they are related to each other. In our first example, we have a very basic question. It's a right triangle, as you can see from this vertex, and we have sides 6 and 11. What is the length of the hypotenuse, the longest side, which is opposite the 90-degree angle? And it's very straightforward. All you have to do is recall the Pythagorean theorem, a squared plus b squared equals c squared, and basically fill in the correct values. So a squared and b squared are the legs of this right triangle, which are 6 and 11. So let's fill them in. We have 6 squared plus 11 squared equals x squared. And this is 36 plus 121 equals x squared. So this is 157 equals x squared, and we square root both sides, and since it is distance or length, we're not going to have any negatives, and our answer basically is x equals the square root of 157. Now we have a distance formula question. What is the distance between the point 4, -3 and 1, 7? And there's actually two ways to solve this. The first, which a lot of people might use, which is direct, is just use the distance formula. It's this distance equals the square root of x of 1, that's the first x, minus x of 2 squared, plus y sub 1 minus y sub 2 squared, and fill in the values. So let's go ahead and do that. So we have the distance equals the square root of 4 minus 1, 4 minus 1 squared is the x's, plus -3 minus 7 squared are the y's, the distance between the y's, and we have this is equal to the square root of 9 plus -10 is 100, which equals the square root of 109. Okay, so that's the distance. And what I like to also consider is this. A lot of times I'll ask somebody, what is the distance between these 2 points? And the student will struggle with figuring out what's the distance formula. They know there's a square root in there. They know there's x's of 1s, y's of 1s, and it's a little confusing. And so usually if that happens, I'll ask them this question: what is the Pythagorean theorem? And they'll immediately tell me, well, it's a squared plus b squared equals c squared. So let's say you know the Pythagorean theorem is a squared plus b squared equals c squared. How can we solve this problem using this formula? Well, the way to do it is simply put it on a graph. So let's do that real quick. Here's our y-axis and our x-axis. And let's just put 4, -3, 4, 2, 3, 4, and -3. So that point is down over here. 4, -3, and let's put 1, 7, so 1, 5, 6, 7 way up there is way up here. So this is 1, 7, and we want to find the distance between these 2 points. So let's go ahead and draw our line. We want to find that distance. Well, if you recall, the Pythagorean theorem uses a right triangle. So let's try to create a right triangle where this is one of the sides. So let's suppose we draw a horizontal line from 4, 3 over to this point, and let's draw a vertical line straight down where they meet. This is at 1, and we have a right triangle. And first of all, we know this is 4, -3. So what is this point here at the vertex? It's 3 units down from this axis, the same as this point. So this is -3. And what is the x-coordinate? Well, the x-coordinate is how far over this one is, and it's 1, because this is the vertical line. And lo and behold, we have ourselves a right triangle. Okay, so what is the length of this side of the right triangle? Well, it's pretty basic. It's the distance from 1, -3 to 4, -3. Which is a distance of 3 units. And what is the distance from 1, 7 to 1, negative 3? Well, it's 7 units to 0 and 3 more to negative 3. This is 10 units, this side. And as you can probably see, this is 10, this is 3. And if we plug that into the Pythagorean theorem, we get 10 squared for this side plus 3 squared equals c squared. And you're probably starting to see the similarity. We have a 10 squared and a 3 squared up in the distance formula. And if we decide to add these together, we have 109 equals c squared. This is our c side. Therefore, c is equal to the square root of 109, which is the same solution as the distance, because basically the length of this side is the same as the distance between these 2 points. Okay, so our third question, we'll answer it both ways as in the previous examples. We want to find what is the length of a line segment with endpoints 1, 6, and 7, 8. So what I like to do is draw a quick graph to give me kind of some familiarity about what my answer should be. And let's do that. We have our x and y coordinates, axes, and this is, let's do this, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. And this is 1 and 3, 4, 5, 6. So 1, 6 is right here. And 7, 8. So this is 2, 4, 5, 6, 7, 8 is way up here. So this is 7, 8. And we wanted to find the length between these two segments. And again, we can use two different methods. We could use the distance formula, or we can use the Pythagorean theorem. So let's start with the Pythagorean theorem, since we've already drawn most of our triangle. If we were to draw a horizontal line this way, and if we were to draw a vertical line this way, forms a right triangle. And this point is 6 units up from the y-axis, from the x-axis, from the x-axis. So this is going to be 6 units up. So this will have a coordinate of something 6. And this point is 7 units from the y-axis, 7 over. So that's going to be 7. So this is 7, 6, 7, 8, and 1, 6. And now we can just fill in the lengths of the sides. And so the distance from 1, 6 to 7, 6 is 6 units. And the distance from 7, 6 to 7, 8 is 2 units. And we have ourselves Pythagorean theorem, 2 squared plus 6 squared equals c squared, see? And this is 4 plus 36, which equals c squared. So c equals square root of 40, or 2 rad 10. And 2 rad 10 is approximately, getting out my calculator, 2 is approximately 6.32. And again, for reasonableness, that seems this side is 6. This is bigger than that, 6.32. And if we want to quickly confirm it using the distance formula, distance equals the square root of x squared, x of 1. So 1 minus x of 2 squared. And then we're going to add y sub 1 minus y sub 2, difference between the y's, squared. And that equals the square root of 36 plus 4, which equals the square root of 40. And it is the same answer.